Hi, and welcome to the news and community stream with Unreal Engine. So our first order of business is we're actually excited and honored to accept the award from Develop for Best Engine. We're really flattered and excited that they would provide that to us, and just thanks. It was awesome. And our second order of business is we have our first ever SIGGRAPH Unreal Engine user group and party. So that'll be July 31st at the Orpheum Theater from 4:30 to 9. So if you're out in LA attending SIGGRAPH, definitely go check it out. There'll be a number of speakers from the architectural firm HOK and animation production company Digital Dimension, Twinmotion, and there's a number of folks from Epic that'll be speaking as well, including our very own Tim Sweeney. So again, if you're out at SIGGRAPH, go check it out. So for our community spotlight, we'll head on over to our answer hub. So every week, those folks that have been answering questions on answers.unrealengine.com earn karma, and we like to give it a shout out, and we really appreciate that you guys are doing that for us. So thank you to Ben Vladke, Matt Williams, Noctmare, Redbox, Azteco, Viva La Bugs, Scott Spadia, Deathray, Shadow River, and Andrew Hurley. So thanks again, guys. You guys rock. So our first community spotlight of this week is Ben de Hullu. He's been building a building constructor tool. So he's set up this modular or tool that you can rough in these shapes, and then based on those shapes, these kits will bash together a house for you or a building. And then you can go in and modify it. So you can see here he's swapping out the foundation. He put that brick foundation in instead of the wood. You can go and adjust the correct kind of roof tile that you would like. But even on the sides of the buildings, you can swap out for windows or different seams. You can add doors into the frames. So we're really excited to see as he keeps developing this tool. It could be really great for throwing together a city and knocking out some buildings really quick. So our next individual is Manuel Fuentes. He's actually built a modular industrial environment. So a lot of it was put together in Unreal Engine. A lot of the textures were built in Substance, and it just looks really, really beautiful. And I love the touch of the covers on the pillars, and the lighting is really nicely done. So great job, Manuel. We really like what you're doing here. And our third and final community spotlight for this week is Epitasis. So in this game, you've actually been launched through a portal and into the remains of an alien civilization. So in here, you're exploring, and you're going to learn how to use alien machinery. You're going to figure out how to power things with lasers, disable security systems. It actually reminds me a lot of The Witness, if you've played that. It's a similar kind of, you're going through puzzles, exploring this world, trying to figure out how to navigate and get through. And so the idea is that hopefully you can escape and figure out maybe what happened to these aliens. And another note, this game is currently live on Kickstarter, so we'll throw the link to that in chat. So if you guys want to check it out and support them, you can. So that's been our news and community spotlights for this week. Thanks for tuning in, and see you soon. So welcome back to the Unreal Engine live stream. I'm your host, Amanda Bott, and with me I have Richard Hinckley and Chance Ivy. So Richard is going to be going over gameplay programming and talking about cameras and just making your game generally feel better.
Yes. So let's see. Well, one of the first things I want to talk about with the game is just that the feel of your camera and how your camera works and what your camera does in your game actually defines a lot of what your game really is. If you think about, for example, a first-person shooter, the camera is actually part of the name of that entire genre, right? It's very important that you are first person in that type of game, or that you're overview in an RTS game. And if you were to change any of those things, you can almost change the entire genre of your game by doing it. So, in terms of capturing the feel of your game, camera and how it interacts with the controls and the players is one of the most important things you have, but it's really easy to overlook. It's really easy just to, put it on a spring arm.
A boom or something that's, yeah.
Yep, and then just go, well, it just stays over me the whole time. I can see all the stuff I need to see. Done. Don't do that. If you want to make the game fun, a lot of times what you want to do, and there's a little-known game developer from Japan. He worked mostly in the 80s, I think. I think he's still there today, but Miyamoto, I think.
It's a guy.
May have heard of him.
Vaguely familiar.
Right. So one thing that he did, and that pretty much everyone does now, is you build that one little piece that you're working on in a separate garden. That's right, in a separate level of its own. So here, what I've done is I've taken the twin stick shooter project, and I'm not sure if, oh wait, that was the right one. Shouldn't have closed that. Anyway, oh, whatever. I've taken the twin stick shooter project, and I've just used that as the base. So in the base project, the camera stays right over your character, which for a twin stick shooter can be okay. Sometimes you actually do want everything, your character to be in the middle of the screen at all times, so that when you go to fire with the right stick, the direction that you fire is always correct because it's always relative to the center of the screen. So that could be a deliberate choice.
Yeah, and you get that specific point of reference to where your character is. Like, I think a lot of those games, too, they start to get a little bullet helly, right? And if you have it moving separate than where the camera is, it's harder to tell what's going to hit you and what's not, right?
Yeah. And so it's not a requirement of that genre, but it's okay. And it's also the most basic way to do it. So our template starts us there. So let's rerun that. We don't actually need to recompile it. So one of the first things that we're going to do in here is we're going to take our pawn, and we're going to make our own camera actor class, and our pawn is, when it starts up, there we go.
You're not going to close it this time?
No, I think this time we're going to leave it open for a little while. And let's see. So we've started here. This is not even an overhead view at this point, but this is just one of the first things that I do to test. I made the pawn, and I had it spawn our own camera class. Made a blueprint for the pawn. Yoink. And set it to spawn our camera. The camera doesn't do anything, but just a baseline. Just make sure that it's actually running your code. Maybe put some debug text on the screen. That's where we start. And this first step, we're just going to show the setup. So let's get back to Visual Studio. All right, so we have two classes that we've added here. We've added my camera actor, and, well, we haven't added this, but we've modified the pawn. So for the camera actor, it's just this. We just need to begin play. And thank you, Vax. And we just check to see who our instigator is. And this is our first little bit of Unreal 4 CPP code today. We always want the camera to do its tick after the thing that it's following. So number one, the camera is not a component. Well, there is a camera component, but the camera isn't just a component. It's actually an entirely separate actor. I don't want it to be hard attached to the thing it's following in any way. I want to be able to choose how it follows. So the camera actor is a separate actor, and it always ticks after. So what this does is we're taking the primary actor tick, which is going to run the tick function, and we add as a prerequisite the pawn that owns it, which we did just null check, and we make sure that it does not tick until the pawn has done its primary actor tick. This is important because if it goes before, then every frame, instead of, if we wanted to stay perfectly above, instead of, okay, render a frame, we would get move to where the pawn is, now move the pawn, now render a frame. And the pawn will jitter because if every frame isn't exactly the same delta seconds, then that pawn will move a slightly different amount every frame. So you'll just see it sort of just jittering around in front of the camera, slightly off center. It's very visually distracting. So that's an important thing to consider right away. In what order do things happen? And the only thing I care about is camera happens after the thing the camera's following. Okay, so that's about all we need for that. And our pawn, upon beginning play, will spawn the camera actor. So we'll look at that for just a second. So we're just going to keep a pointer to our camera class. And in the editor, we're going to expose a field here. This is a T subclass of a my camera actor.
I love this.
Yes, this is one of my favorite things. And yeah, actually, what we were just talking about with the Robo Recall mod, that's, yep, you need that. Now, I could have made this a actor or a camera actor, but I want to make it as specific as possible while not being too specific. So a my camera actor is going to be the base class. If I have a second camera class, then I would probably make an a my camera actor base class and then derive the first camera I made and the second camera I made both from that class. Since we're only doing one class in this project, I didn't bother with making an abstract base class. I also could have just used a camera. But the reason you use this is basically, what if there's an a my camera actor function that I specifically want to get at? In that case, if I use this, then I can store the camera here, and then I don't have to cast it every time to get to that set of functionality. So that's a habit of mine, but I think it's a pretty good one. It avoids a lot of unnecessary casts on every tick. Okay, so, oh, and this being exposed here means that when I go to my editor and I go, what do I want here? The choices are the C++ class that I created and the blueprint that I created. That's it. So it's filtering what shows up in the editor here to the class type and the child classes of that class that I selected. Saves a lot of time. And prevents you from putting in some actor that's not actually a camera.
The wrong thing and then failing on that cast anyway and your logic's not working, right?
Yeah. I also check right here. This is basically like an assert, for those of you familiar with that. So if someone fails to put a camera, if they just leave it as none, just crash. I don't care, just crash. We could end the game here, but you know, we could get out of this more gracefully. We could despawn the pawn. There are a bunch of other things to do, but at some point, that's okay at first. But at some point in your development, you usually actually want to force a crash if someone does something like that, because you want bugs like that to be noticed. You actually don't want your game to smoothly recover, and then when the game gets out there, someone goes, you know, if you go through this door and then jump off this cliff and then go back in here, you don't get a new camera, and it's just a black screen, but you're still running around playing the game. And we don't know why.
It'll be easier for you to breakpoint through this and walk what's happening and find the exact piece of code, right?
If it crashes, it will not be ignorable. Your development team will have a much harder time failing to notice it as it goes out. And remember, your players in the first couple hours, maybe the first day, have played more combined hours than your entire QA staff for the entire development time. So they'll find it. All right, so we want to spawn this thing. And originally, I thought, you know, let's spawn it, and then let's just tell it what pawn owns it, because it's going to need to know that because it needs to know who to follow. I'm using the instigator field because that's already built in, so why not? But this is too late, because if I spawn it like this, it calls its begin play function, which is here, and checks this before instigator is set. So again, just like with the tick thing, the order of operations is really important. So we don't do that here. Instead, we use our spawn parameters. I want it to always spawn. I don't care if there's a solid object there. I need my camera. And we could resolve collisions later. This camera is not going to resolve collisions. It's an overhead cam. It's not meant to go indoors or anything. That's more complex than I wanted to cover on the first day. And the spawn parameters happens to support this, most likely for this exact reason. So there you go. We take our camera actor to spawn. We get its class default object, and we get the class of that object. The reason we don't just get the class directly from this is because this could just get blueprint generated class and tell us that it's a blueprint, which is not really helpful. We want the actual object that the blueprint is talking about, which is the camera object, and get that thing's class. And that's about it. And we spawn it with the same transform as the thing that spawned it, which is why when we start the game, you can kind of see the edges of our vehicle right there. We're actually in the camera, so that's why that's there. So all this tells us that stage 1 worked really well. Oh, right. And we take our player controller and set the view target to the actor that owns the camera. Okay. I've done this as a series of 6 projects with just a few steps taken in each one. So we actually have 6 different projects we're going to open up over the course of
And
this.
is this something we could upload
Oh, yes.
later
We're definitely
for
going to upload
folks?
this. Yes.
Okay.
Yeah. So let's see. All right. So we're back in my camera actor again. And here we're going to start adding to it. So, yeah, this is 2, right? Okay, so the ideal offset. The ideal offset is going to tell us basically how far away from... So you take the actor that you're following and just how far away from that do you want to be and in what direction. Pretty straightforward.
Mm-hmm.
And then what we're going to do is every frame... Okay. Every frame... color my stuff, please. Thank you. Every frame we're going to see where the actor is that we're following, and we're going to move away from it by that amount. So
they're wondering what's the difference between the previous project you had and this one?
Oh, it's this.
Just the section.
The exact thing we're talking about right here. So this variable, ideal offset, did not exist before, and the tick function did not exist before. And, whoops, am I in here? Yeah, here we go. And the other thing that we're doing here is this part. So before we just checked that there was an instigator and we didn't really do much with it.
Mm-hmm.
But now we're going to take the instigator's location plus our ideal offset. So we're going to move to our perfect ideal position to start. And then we're going to use this function, find lookout rotation, where we will get the... So it's supposed to be basically the start point and end point, but since we know what the difference is between them, we just use the difference and 0. And we get the rotation of the camera. And I think I'm already running this, so now we have this. Now, to the untrained eye, it would appear that we've just treaded water, as this is what the project did by default. But we've actually done something in that this is now our own thing that we're controlling with our own tick function. It's not just an attached component that we have that we haven't done anything with. So even though this is functionally identical to the template, it's different because we have the setup now to do whatever we want with it, and it's not rigidly attached.
Okay.
So that's a pretty short step, but I just wanted to show coming from nothing into nothing that we have control over, which is actually a big difference. All right, let's go. It's going to start getting faster from here.
Well, don't talk faster.
I can't talk any faster than this. I'm getting through this first part, so I know I'll have...
I will teach you.
I know I'll have the... I know I'll have the time to get through the later parts. Okay. So right into here. All right, so the camera actor is pretty much the only thing we're going to need to modify from here on out.
Mm-hmm. We've
We've basically done everything with the pawn. All we really need to do is to spawn it. And what's nice about that, someone asked a question, this is like a QA question, but a Q&A question, but we'll get to it now, about portability, about moving your code between different projects. This is a good example of where you can do this. I didn't do this as a plugin, I just did it as a class, but this camera class could be easily moved because the pawn doesn't really have to talk to the camera a lot. The camera just sort of looks at the pawn, figures out what it wants to do, and does it, which makes this a really good candidate for code that you just straight copy over to another project, which is just the easiest, simplest way to port code. Plugins are nice, but plugin was overkill for this, and we've done streams on plugins before. All right. So now you can see our tick function is starting to get a little bigger. Let's see what else is in here. So we put in, all right, show debug info. You really want to see some stuff when you do these cameras. You want to see, trails for where the camera's going. You want to see boxes around, what areas of your screen the camera thinks it's looking at. All that kind of stuff is really helpful to have. and putting in something, just a little bool like this that you can just turn on and off in the editor to show it is very, very helpful. I highly recommend doing this because cameras have a lot of really subtle behaviors. And by the way, if you're trying to emulate a camera that you've seen in another game, record gameplay footage, and when you review it, like, don't write on your screen, but I don't know, put a little piece of tape up at your screen or something like that. Like, look at what the camera's doing frame by frame. There's a lot of really interesting stuff that happens, really subtle stuff that contributes to the feeling of a really smooth camera versus a kind of janky camera that's very hard to notice if you don't do that.
And it makes all the difference, right?
Huge, huge difference, yeah. It's biggest difference from tiniest things. All right, so we still have ideal offset. Now, we're going to limit the camera speed, and there are kind of two ways to do this. One is per axis. So you'll say, like, it can move this fast on the X, but not quite as fast on the Y or something like that. And just as a radius, just in all directions combined, the total amount the camera moves can't be greater than this. I'm supporting both in here, which is maybe a little bit of overkill, but I've sort of clearly marked out this one does this one does that. All right, so right up front, we're going to figure out a bunch of things that we generally need to know. Where do we want to be? This is where we'd be in an ideal world. Where are we at the start of this whole procedure? What's the difference between those two? And then how much of that can we move during this particular frame? And that last one's important. Remember that your speed is going to be units per second. But if this is a 60 frame per second game, you just ran a 60th of a second, so you need that delta seconds in there. A lot of camera mistakes, like if your camera just suddenly flies off into nowhere for no reason, probably you used an unscaled speed, so something moved 60 times as much as it was supposed to every frame, which will very quickly push your camera to its limits. And then finally, right at the end here, we have the final, like, this is the amount we're actually going to move this frame. So basically, this just means that our camera will only move at a certain maximum speed. If our character moves faster than that, the camera will lag behind, and then if our character stops, the camera will catch up. And then as long as it's actually moving, we're going to draw a little line if we have our debug info on. You'll also notice for shipping builds, I don't do this. Of course, you know, when you ship your game, you turn off the debug stuff.
You can just drop this in there too, right? That the if debug UE build shipping, this will just make sure that you don't have to go in here and comment it out later.
Yes.
Yep.
Yes. So it'll be in your development and debug, and this is just built into the engine. I didn't write this thing. It's just there when you compile up here, or when you package it from the editor. It's just handled. All right. So pretty simple stuff. We clamp our movement either per axis. So here, this is a hard-coded 3 because it's 3-dimensional space. So if we start existing in 4 dimensions, I will have to revisit this code. But I feel like this is adequately future-proof.
Yeah.
And we could just take each component and say the amount that it can move is right here. It can't be greater than the magnitude that of the maximum per frame. Again, per frame, so we've got that delta seconds. And that's it. The amount that it wants to move versus the amount that it can actually move. And then the same thing here. Get clamped to max size basically takes a vector and just shrinks it down until the total length of the vector is what I tell it to be, which in this case is the radius movement per second times the number of seconds. So hopefully that's pretty straightforward, and I am running this, right? I did hit run. Good. Okay, so now as you can see, you can sort of, I don't have my mouse. Can I still move this? I can't. Okay. Yeah, unfortunately the mouse cursor is not going to be visible. I should turn that on. But you can kind of see that I'm getting away from the center of the screen, and then when I stop, the camera continues to follow. So the camera's a little smoother now. Here's one problem with it. I can outrun this. If this runway were a little longer, if there weren't a wall there, I could actually have run my character all the way off the screen.
So you're saying you need a max distance from the player to actually clamp down to.
Yeah, that would be a good idea. So here we have some things set, and you can see, oh yeah, this I like too. I didn't put categories on everything, but by default there's a category for whatever your your class name is. In this case, the blueprint is called Chase Cam, so it's Chase Cam. And so you can just see our fields are all right here. So yeah, our speed limiter is right there, and here's our speed limiter on a radius. So I'm going to make this so high that it's a non-issue, right? Like it'll never clamp to that because these axial speeds will clamp it first.
Got it.
So that's kind of what we already had, but you can see, whoops. Right, you can see like I can still outrun it a little bit, but not on a diagonal, because on a diagonal, I'm moving on the two axes are now clamped separately.
Got it.
So that's why I can't outrun it on a diagonal, but I can outrun it sideways. So if you had a game like, the original Legend of Zelda where you only move up, down, left, right, two axes might be what you want. If you have a game where you move freely in 360 degrees, you probably want to use the radius to clip your speed. And here, the yellow line shows us where the camera is. You'll notice that as I get ahead, the line's not fading, it's actually behind me because I'm outrunning it. And then when I go around corners, you see how it catches up? Because it's clipped separately. There it went through a wall corner. Like if I really cut it close, I can make it go through the wall. That sort of thing.
But you don't have to do any culling because it's so high, right? There's no collision for the camera in that geometry.
Yes, yeah, that
Cool.
would be not a problem for this type of game. So that's kind of a useful thing. And you look at that pattern. That looks weird, though, right? I mean, I kind of moved on like a looping pattern, but it's really sort of hard on those 90 and 45 degree angles. That's the kind of information that you want to have debug visualization for. Still getting that same problem. So we'll address that. Oop, next one.
Part 4.
That's right, part 4. So now we're getting into the really good stuff. All right, not this one. And we're here. Thank you. Okay. So, distance limiter. So clearly an experienced programmer. You just knew that's where we were going. But yeah, that's where we're going. All right.
Sorry to go ahead.
No. That's perfect.
Jumping ahead
Reveal
in
the
class.
secret. Yeah.
That's perfect. Yeah. So okay. So we want to make sure the camera doesn't go too far. So this is sort of another order of operations is almost the theme of this. I'm going to take that delta location variable that I calculated up front. And one reason I calculated this was for the convenience of not having to write ideal location minus current location constantly. Another reason is so that it decreases the likelihood of me making errors because I don't have to do that. It makes my code more readable. And also it's more efficient than me doing a bunch of vector subtraction operations every time I need to know the difference. If I know I'm going to need it 10 times, just do it once. But the other advantage to that is that I can change it. So right in here, I can clamp it. Right? So I can say if you think that your delta size is, there we go, much nicer. If you think that your delta size is too big, then what you do is move the camera automatically by the excess amount and then reduce the delta size by the excess amount. So if I'm only allowed to be 8 units away and I'm 10 units away, immediately move me by 2 units. And then say that I'm 8 units away instead of 10.
Okay.
And so to do this, we have a movement this frame due to cap, because I'm writing short novels with my variable names. So this is separate from desired movement this frame because it's not going to be subject to any of those limitations that we had before. The camera speed, that doesn't affect this. When you're out of bounds, you get all that for free plus this frame's movement.
Got it.
That's how I've decided to implement it here. You could do this frame's movement and then clip it to bounds if you wanted to. That would be fine too.
You can try both and see what feels better, right? If one operates separately than the other.
Yep. I actually think the other way might feel slightly better. This way might be a little bit more jittery. If you're going really fast, it could be jittery. But whatever. You can change the order of operations to be either way. In this case, I did this first, and then this is the same code as before, and then at the end, we just add in our extra movement. So we move it by the desired movement plus the movement we're required to do by the cap. And now we can't outrun our camera anymore. So let's get all the way up here. Let's get all the way up here. And, and since I made that debug thing visible or editable anywhere, that means that I can take my camera actor in here. These windows could be a little bigger.
What?
Where's my debug info? Maybe I'm making a mistake here. I'll speed this up by just going straight to it. Anyway, you should be able to edit this in the editor. I'm not going to fish through and find it right now. Am I in the chase cam? Yes, I am.
Did you name it something different?
I don't. Oh, whoops! I don't. Never mind. Some of these I went back and edited out of sequence. So this one actually doesn't have debug info in it. I'm just looking at the code right here. It's not here. So never mind. We'll do the debug info in the next one. So anyway, but we'll still show this. All right. So we go to the bottom. We run to the top, and you see right about there, we're no longer making progress. We'll do it again to the bottom, and right there, we're no longer outrunning the camera.
Oh, yeah.
And we can clip it down even tighter if we want. Just, that was never going to work because it's not here. But yeah, camera distance limiter, and we only did a per axis one, but let's make it like 200. That's fine. Oh, you know what? We could even make it pretty wide on the X, but pretty narrow on the Y.
So you can really see it.
Yeah, yeah. You can kind of compare and contrast. So
and it would be cool too for some sort of like side-scrolling shooter or whatever. You might want to do that so you can move quickly this way, but not as quick forward, but maybe faster backwards. And at the same time, your clamp box could be a little bit broader or narrower based on where you're working.
Yep. Yeah, that's exactly the kind of thing, right? That's like this game would feel this way if you did this. So right here you can see I'm in the middle of the screen. I'm barely out of the middle of the screen. We've already stopped.
Mm-hmm.
That little bump is all it took to catch up at the end, just that. Whereas with this one, I get pretty close to the bottom before it stops.
It's nice.
I'm gonna close both of these before I open the new ones because I can see what will happen if I don't.
And I imagine it's possible to like soften those up and smooth those out, so it's not just like a hard bump that you could kind of ease out of it.
Oh my gosh.
You would imagine.
That's what I want.
I know. I may or may not have already programmed that in.
Oh,
yeah.
goodness.
So,
Your code voodoo.
So, all right. Here we go. We have, all right, so here we have our speed limiters per axis. And we have debug info again.
Woo!
Yeah, I don't know what I did there in 4. I guess I just forgot to, like I said, I edited some things out of sequence. Sort of hard to keep it all together. So good. So now we have some serious debug info in here. So I guess at this point we should probably talk about what the debug info is. So we still have our clipping, right? This is our sort of safe frame, and this is what we did with the max distance last time. So what we're gonna do, here is our, oh yes, and here I did change the order because of that feel issue. So here we clip the speed, we clip the delta rotation here. Or the delta location, not delta rotation. And then we clip our desired movement here. No, sorry, I didn't change the order. We clip, I thought I did, I didn't. So we're gonna clip here as we did before. This code is pretty much unchanged from the start. And then we're gonna clip here, and we also have a radius clip now, which is a pretty similar thing to what we had before. The interesting thing to note is that I clipped by radius first and then by axis second. And that will affect what happens if you're above and to the side of the safe frame area. And we also have a bunch of debug info now. So we're going to draw a thick yellow line for where we've been, a green box for our axis limits, and a green circle for our radius limits.
And I wanted to reiterate on this, the importance of this. I would say, like, if you're wondering what's going on inside your game, this is like drawing out debug boxes, lines, anything while you're testing an editor. So valuable. I mean, there's so much you can do in breakpoints here and watching values and blueprints, or even here in the source code. But actually being able to visualize it on screen is it's so powerful.
Oh, and a quick thing on that is at the console, you hit tilde to bring up the cheat command console. Show space collision. That's a really good one. That'll draw shapes for your in-game objects. Really good for bounding boxes. Anytime you're doing like a fighting game or whatever, it's really good to know, like, oh, the hitbox is the wrong size in this frame. That's why I'm immune to this for some reason.
Or, oops, my skybox has collision on it.
Or yes, I can't walk through my area triggers. Yeah.
Missing your collision.
So we play this, we move around. We still have. It's still kind of hard though. Look at that hard stop. Ugh. Amanda does not like that at all.
I don't. It's the artist.
Also, so do all video game players, whether they realize it or not. That's another thing too. When you're playing a game and it just feels really good, the camera's kind of one of those things, you don't notice it, right?
You never think about it. That's how you know you're doing it right.
Yeah.
If the player's not complaining about it, it's because they're not noticing it, right? Like, and that's good.
It's just like theater. That was everything in it. Like, if there was no comment on the tech of the show, then you know you've done a good job.
Right.
Yep, that's right. Yeah. Noticing the tech is not what you're supposed to do. Okay, so there's our save frame, and there's our extra thick yellow line. I don't know if you guys could see the previous line on the stream. So that camera's really angular. I mean, look at that. And when I get outside, you see when I get outside, it starts to get a little bit, it's like not always on 45s because I'm outside. So that's a little bit better, but still, the camera's really angular. It feels weird.
Is there any way we can, curve some of those things out, maybe?
There might be. So I'm gonna put the distance limiter. You may have noticed that was set to float max before. This is a giant number here, but that number, I'll show you where that is in code. That number is, I set all my initial values to things that I thought were pretty good. Your designers are probably gonna tweak these, but it's nice to have like a suggestion or whatever. And
good fallbacks, right?
Yeah, just decent fallbacks. And this float max right here is the highest number that can be defined by a float. So 3.4 times 10 to the 38th. It's pretty big. So that way I know that that's never going to be a factor, basically. The other thing you can do is just do that. But we actually have a specific macro for that. All right, so we'll put that back down. And now you'll notice that since it's not drawing a gigantic thing, now you can see there are the circular limits. So this is at least a little better. I can't get out from the sides as easily. It sort of follows me a little better. It's fully
normalized, right? Yeah.
Yep.
Same distance from the center.
Yeah. So I have a nice circle, technically a sphere or whatever, I guess. But since our camera doesn't move on the Z at all, it doesn't matter. Still though, the camera's still kind of hard on those 45s. And it still isn't really smooth to slow. But now we've got really good debug info, so we can see that. We could screenshot it. We know that we're actually correct when we talk about how this works, and we can start putting limits on things and testing them out a little better. Bing. All right, and then. All right, now we get to really good stuff. It was really interesting to build this in little stages like this, other than the fact that I had to go back at one point. But just to put in all the little upgrades. So, right, as Amanda pointed out, it doesn't feel right to have a camera just start and then stop. There's no speed up, there's no slow down, there's just rough robotic camera that feels weird. I can only tab back so many times.
What?
So here we're going to add some things. So this one's a little more complicated. Not too bad though. So we'll get to that in a minute. We have all our limiters, all our debug stuff as usual. We're also going to have some speed adjusters. So what our speed adjusters are going to do is they're going to tell us, well, that was my fault. They're going to tell us that when we're moving when we're within a certain distance of our ideal position, we can have a multiplier. So we could say, generally it would be if you're far away, you get a greater than 1 multiplier, and when you start to get close, you get a lower than 1 multiplier. Now the thing is that would result in your camera going, right, like fast, 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 okay, middle speed, okay, low speed, and it would feel kind of weird. So we are going to use some of the maths to smooth that out.
How many maths did you bring?
I brought 1 math per axis, so there are
great.
4 maths in this.
4 math.
4 maths. So we're going to have 4 axes. It's an enumerated type here that I'm going to call chase cam axes, and I'm going to make these bit flags because I didn't want to have 4 bools. I also wanted to be able to check these things just by saying, do you have this flag or not? Because that way I could put it into a for loop, and I wouldn't have to write a different piece of code for each bool.
Right.
And I wouldn't have to make a weird like T array of bools or something. I didn't really feel like doing that either. And actually normally you would do that. Oh wait, no you wouldn't. Normally you would do that, but not for bit flags. Bit flags are a feature I don't think people know about too much, but basically it allows me, if I tag an enum with bit flags, and then where I use it, I say
You can use a
it's
mask.
that class's bit mask. Then in the editor we have support for this. So I don't want to go too far ahead, but I just want to show you what. Come on, there we go. This isn't Max, that's why that happened. Okay, so we go down to our chase cam section, or we just give me my chase cam section, and now we can do this, and I can check flags, whatever. The editor just supports it. And you notice if I have only 1 flag, it actually says what it is. No flags, it says what it is. Multiple flags, I mean, it's only got that much space, so it just says mixed.
Yeah.
But it works pretty well. Okay, so that it's just bitmask and bitmask enum equals the class name, and this is actually just an int, which is also nice because I don't have to cast it. Normally, if you want to compare an enum to an int, you have to do a lot of casting to int32, which is just this, int32, the enum value, just that, not like a cast like that.
Right.
Not that. That's too much. That's for UObjects. So, okay. Let's look at our speed adjustment. So that's down here at the bottom. All right. So we're going to adjust camera speed based on distance, and we're going to do it smoothly. We're going to look at radius adjustment first, and this comment is actually incorrect. Originally, I had it, if you did it for radius, it wouldn't do it a second time, but I think that's not the case. So, there. All right. So what we're going to do is, for each of these, we're going to see what axes it applies on, and then the limiter itself is going to have a distance range. So your camera on this axis, where the axis is either, X, Y, Z, or the radius, whatever axis you determine, you've got that one dimension. You can be between a minimum and a maximum range, and it will use this multiplier. And the speed multiplier basically says, all right, so like 0 would be not moving at all, 1 would be full speed, 2 would be double speed, and so on. So if this is from, let's say, 10 to 100, and this is from 0.5 to 1.0, then over the range of 10 distance to 100 distance, you will ramp up smoothly from 0.5 to full speed. So that way,
Gotcha.
we don't have quite a curve, but we can have very easily multiple line segments that connect to each other. And that will feel pretty smooth as long as we don't have an absolutely terrible frame rate. And then these are just the axis flags to say which axes to apply this to. So any one of these cam speed adjustments can apply to any number of axes. All right, so then all we need to do to get them in there is we just add an array of these. I'm going off of the assumption that you're only going to want one of these at a time, but you're going to have multiple distance stages that could affect your your speed. So we're just going to take our movement, our max movement per frame, and this is the beauty of it. We're not saying how much we're moving. We're saying how much we're allowed to move. So that amount goes up or goes down based on these scalars. And for any one, the check is pretty simple. We look at, we're going to look at the axis ones. The radius one is right here, and it just uses the total distance. It's the same math basically. But I'm going to take that component, and if that component is equal to what you would get if you clamped it between the minimum and maximum, then that means it's in the range. If it's in the range, then scale it by, and then this is a really convenient function because I can take the distance range and the speed multiplier range and then tell it where we are in terms of the distance, and it will scale it down like accordingly. It'll just, that one function will do that whole scaling process for me. So that's pretty nice. Once that's done, we've now adjusted how much speed we're going to permit. So as you can see, I made two scalars. I made one that says that when you're right on top of the camera or you're up to 200 units, you move from 10 to 50% speed. I didn't make this 0 because if you make it 0, then as you almost get to the camera, you'll just slow down, and your camera will sort of like really slowly tick toward being over the thing, but never really quite reach it. So I just bottomed it out at 10%. And then if you're at 2 to 300, it speeds up a little faster. It goes from half speed to full speed. So by the time you're past 300, there's no limiter for that range. It just goes full speed. Here's what that feels like. You can see it slow down gradually. It speeds up, slows down gradually. This also creates the effect of the camera actually being a little bit curvy. You can see it's not going on like super hard 45s. It's curving the corners. It's still sticking mainly to 45s though.
It's making the correction slowly as opposed to immediately, right? While you're moving around those things, it's a little bit of leniency.
So let me see, what can we do with that? And also one other reason that it's still going to be a little 45y is because I'm not using analog stick.
Right.
I'm moving on hard 45-degree axes, but you can see it trying to curve to compensate. I'm going to limit it. Oh wait, no, I'm not.
And what you would expect with a stick would be, without any of this easing, you would just have up, over, it would go directly the direction you're going, right? Whereas this would give it a little bit more of a curving into it, right?
Yeah,
if you're
so
using a stick.
you can see if I get away from it a bit and I start doing this,
Yeah.
that's a pretty smooth, that's not really all 45y. There you go, feather that a little bit. You can see that's actually pretty nice and curvy up there. So it's because I'm moving on hard 45s that it doesn't look as good, but if I had an Xbox controller hooked up, it would be fine. And I can still kind of trick it into doing stuff like that. You can see there's a nice little curve to it. You can draw a little figure 8. I wish I had MS Paint to draw this figure 8. But yeah, that's a pretty...
Did something happen to MS Paint?
No, I don't. You're right.
It's dead. No, they killed MS Paint like after 32 years.
Did they?
It's a sad day.
That is a really sad day because I loved using that.
You just want to be an artist. That's
I
what you really
do.
want.
I just want to draw binary trees and stuff for people. So now at this point, I think we have a camera that basically it feels decent. It doesn't jerk start and stop. It has reasonable limits to its range. I can't go off screen with it, and it will curve and follow and slow down and just sort of gently settle on the middle of on the middle view. So this is now the basis of a camera that to me feels okay. Now you run around and shoot in every direction at all times.
You know, I was thinking while you were building this, a couple of questions.
Sure.
Do a lot of these same principles apply if you have a character that's going to have variable movement speeds. For instance, like if I'm playing a game like this where I'm shooting whatever, and then I hit like a jump pad that like quadruples my speed in a direction, the camera behavior should still maintain a bit of that, or because it's following me to a specific depth, right? And the speeds will only adjust as I adjust my speeds, right?
Yeah, I think this camera would actually handle that okay, because you have the you still have that you have the big circle at the end.
And that's where it's stopping its thing, but it's following you.
Yeah, so if
Right.
you shot ahead, the circle would drag the camera
Right.
with it at the back of the circle, and
Gotcha.
then the camera would come up. Another thing you could do, still without changing any of the code for this system. Actually, there's one thing I wanted to do, but I'll do this as well. All right, so we can still get to the edge of the camera, right? Let's limit our distance to be a little tighter, just so we can get to the edge of the camera and start dragging it a little bit more quickly. You can see it's a pretty nice curvy. So what we would do there is we would add another limiter, and let's say from 300, so 400 is the max distance before the hard limit. So let's take that. We'll start at 1.0, so it's continuous with this, and we'll go up to, I don't know, double speed. So imagine if this isn't going to look quite right, but you see how this. You see how it kind of it's chasing us
Right.
just like a little faster when we get out to that end
Right.
range? Let's make it even more extreme so we can really see it. This is a bit ridiculous, but not even faster than that.
4-0. No.
I think I've actually never tried doing higher than 1. The code might be in the wrong order to support higher than 1. Oh yeah. You can see when it comes back in, it sort of zooms. We're still outrunning the camera's top speed. Which is the main issue. So you'd have to tweak the camera's top speed. It's 600. I think the character speed in this is like 800. So you might want to tweak that. But yeah, for a burst of speed, if you could imagine that that's your burst speed and not your regular movement speed,
Right.
that would work fine.
Cool.
Another thing that looks pretty good here is a dead zone. So I'm going to move this one up to 100 to 200 range. And the 0 to 100 range, no speed. So games like Super Mario World is well known for this. If you stop the camera, if you're walking forward in Super Mario World, the camera goes a certain distance and it stops. There's a little area right in the middle of the screen where you can walk back and forth where the camera will not adjust. You have this little window so you can make fine adjustments without the camera, flying around on you, especially because that game does, well, I think it was a couple other things with the camera that I'm not going to go into right now, but you can see. Whoops, wait, I did that wrong. 0 to 1, let me insert one here. 0 to 100 should be 0 to 0. Don't need this one. And I do need to tell it that this is a polar. Okay. So here, now there's a little dead zone. I can move around a little bit in here without the camera getting all, is it froggy? I don't know. Whatever that word is.
That's great.
See, and if I just sort of edge it, it'll kind of edge up on me. It won't
Right.
It won't lock with me
And
like
you
I
can also
hit.
put a little circle in there too that shows that dead zone if you wanted to draw it out, right?
Yes, we could go into the debug and draw either. Oh, you know what we could do? We could draw just the active debug zone, like
space.
just a red
Yep.
circle to show the limiter we're using now, or we could make a bunch of red circles and draw every limiter that we have.
That actually, as you hit them and how they feel. Yeah, that's nice.
Yeah.
Cool.
Yeah, or we could draw just a yellow circle for the one you're hitting, a red limiter for the one you're hitting, and a yellow for the limiters you're not hitting.
Yeah.
So yeah, I mean, lots of stuff we can do there.
Debugger.
Yeah. Okay. So that's our basis for a camera. There, we've got the unplanned hyperspeed extension. We've got the dead zone. We've got smoothing. We have axial and radial damping and clipping limits. So all that in there, and now we have a camera that feels reasonable to use for whatever type. I mean, it depends on what type of game you're making. So I'm kind of making a camera for no specific game here.
Right.
But you can see how with the yellow line, you see how the yellow line is much less active now. So if you didn't want the screen to jiggle around a lot, that dead zone
That's really, really nice.
adds a lot. And that was just data. I actually thought of the dead zone idea after I wrote everything else, and I was going to write code for Dead Zone before I realized that I absolutely did not need to do that. There's already something for it.
Yeah, yeah, and I've noticed too a lot of games like that that'll do that little bit of movement. I mean, it's even if you are kind of in what you've defined as a dead zone, the camera will just kind of slowly correct to you. Like if you're not moving, again, like it'll after some time it'll go, oh yeah, I need to move over. So this is great. There's so many little tweakable variables here, and I'm sure that a lot of this will also apply to 3D movement too, right? Like since you're really just working from axes here, right?
Yeah. So,
yeah.
The lazy
so
cam.
there's
great.
so that little movement doesn't do anything, but then it just slowly catches up with you.
So good.
You mentioned having a delay before it does that. All I did was turn this to 0.1.
Yep. Yeah.
But yeah, I mean,
That's same effect, right?
yeah.
Yeah. Super
But
cool.
okay, I think that's most of our plan stuff. We had a few questions that I
Yeah.
saw that I wanted to get to. Let me see. Okay, a few minutes on setup of a basic RTS camera. So what we had actually way in the beginning of this, just like the twin stick shooter, that almost is an RTS camera. Because with an RTS camera, when you press the arrow keys, the camera just moves, and it's
Right.
usually pretty stiff because players kind of want it to be that way. They don't want the camera to slide. That's the thing, right? Here we want the camera to slide because we're not directly controlling the camera. But in RTS,
Right.
you directly control the camera. You don't usually want it to slide because you move the camera over, then you go to click on your units,
And then it's still moving.
and they're moving
Yeah.
under your
Yeah.
mouse pointer. It's very annoying. So RTS cams are purposely rigid. They would work just like the original twin stick shooter setup. There's also usually a mini map, but in the Learn tab we have a project called Strategy Game, which has it works on a phone. It also works on desktop, and you move the mouse to the edge of the screen and it slides the screen. There's a mini map. You click on it and it goes to there.
Pops you back.
So it's got all that kind of stuff. And the key there is that you would have your camera object, and then instead of tracking any specific unit, you could track a specific unit if you wanted to just watch my hero or whatever, like in a replay. But otherwise, you could have an invisible, non-clipping, basically follow point. It's just an invisible thing that floats around, and your camera just follows that.
It's just like an object, right?
Yep.
Just a basic object.
Just any. I think it has to be a pawn to use the instigator field, but
Right.
it doesn't really matter. Get actor location is the only thing we call.
Take
so.
your pawn and strip everything out of it to get it as minimal as possible.
Yeah.
Cool.
So yeah, an RTS camera would actually be simpler than this one. Let me see.
Cool.
Organization of code. So again, I kind of touched on this earlier. So basically what I did here was I said, all right, what is the minimum information that I can give to this camera for it to do its job? And I decided the minimum information is knowing who you're following, right? And then the rest of it, the camera code has everything else. All these variables in here are all part of the camera. It doesn't have to ask the pawn anything except where are you. If you wanted it to ask more, if you wanted something like, if you had a game where it's not, you can't just ask your pawn what its rotation is, because maybe your pawn is facing this way, but you want to look that way, or
Right.
your character is locked on and aiming a gun at someone over there while you're,
Or
you know,
you might have a
anything like
very
that.
complex pawn that you want a specific component on it. That's information instead of having to pull all that and find where it is in the tree.
Yeah. A lot of those games, you click the stick and it rotates to where your pawn is facing, which might not be where the camera was facing, stuff like that. In that case, what I would do is make a U interface, which you can do pretty easily right down here. Make a U interface, have your character class or your pawn class or whatever use that interface, and then your camera can query the interface when it needs to know things about that actor. And that way, you can take the interface and the camera class together over to a new project and just implement the interface on your actors in that other project.
Got it.
You don't have to take an actual base, like, modified pawn class over.
And move it over too.
Yeah.
Cool.
Okay, custom player camera manager. Someone does not understand why you would want to make a custom player camera manager. Like, what would you do there versus just making pawns or controllers? Well, in this case, I actually didn't even really make pawns or controllers. All I did was put a spawn function in the pawn. That was it. Player camera manager is something that you really don't need to override very often. You can, but you don't need to. The main thing that it handles is blending between cameras when you switch from camera A to camera B. So if you have a special way that you want to switch, like, for example, I think we have a bunch of common things like ease in, ease out for transitions between cameras. But what if you want to use a U-curve float asset so you can define your own custom curve to define how you blend from one camera to another? Or if you want a camera that when you start blending, it takes a screenshot so you can like crossfade it. Final Fantasy X, I remember, did tons of crossfades.
Right.
It's like they discovered that you could crossfade, and they did tons of crossfades in that game. So whenever they would switch views, they'd crossfade it out, which is, I mean, it was an early PlayStation 2 game, so that was new. You couldn't do that on PS1. So if you want to do something like that and just have that functionality built in, so you don't have your designers having to do it all the time, then that would be a reason to override those. But generally, I think the Player Camera Manager supports enough options that you probably don't really need to. Okay, switching between two cameras that are on the same actor. So the trick there is on the same actor. And I guess you could do this if you wanted to snap cameras in like a first-person shooter. So that would be a good reason to do it. Normally, you just do two separate actors, right? Like my camera is on an entirely separate actor from the thing that we're following. The way you would do that is you call activate on the new camera, on the component, the new camera component, and deactivate on the old camera component, and that will switch them. If you want to do it a little more smoothly, you might want to have the old camera snap to the position of the new camera and then smoothly move to where it wants to be. But if you want to snap, if you have like a fast-moving shooter game and you just want to snap right into my sights and then right back out, then maybe you don't do that. You just deactivate, activate. I would generally use two separate actors, but I understand if, because there aren't that many players in the game that have cameras on them. It's usually like one player that has cameras.
Right.
So it's not like you're putting two cameras on everything in the game. It's like you're putting two cameras on one thing. I would probably do that. But if you want to do it the other way, activate, deactivate on components is how you do it. Now this one, I'm going to start answering, but there's no way I'm going to answer this one. It's basically how do you make a camera interpolate to going behind the player once they start running towards it, like the Batman Arkham games. So those games are incredibly well designed. I've just, even from the first time I saw it, I was really impressed by those games. And they clearly put a lot of attention into all their subsystems. So there's no way I'm going to tell you how to make something as good as Batman right now. But yeah, suppose you've rotated the camera around, it's in front, and then you start walking past and you kind of want the camera to follow you. Basically, what you'd want to do is look at the thing you're following, look at where the thing you're following is going or headed, and try to approximate where you think it's going to be half a second to a second and a half from now, depending on how tight you want the camera to be. And slowly track toward that. And use a similar system to this, where the further off you're looking from where you think you should be looking, the faster you correct, and you kind of just smooth that out. You could use something like the speed adjustment limiters that I made in this project to accomplish that, but it is pretty tough. You'd also probably have a repulsion zone around your character where if the camera's too close, it pushes back.
Repulsive.
Yes.
Yeah.
You want that little, because you don't want Batman's face to clip right into the camera, right? You want the camera to kind of stand around him, which also makes him feel cool, because it feels like you just got out of this guy's way. It just makes him feel more present, because the camera's like, whoa, it's Batman. Go by, sir.
Step aside. Yeah.
Yeah.
So I think we have time for one more question.
Okay.
Yeah, I've got one.
All right. Yeah, I was just trying to rush through these
No, you're
as
good.
fast as possible, but not that. Let me see. Should the camera be in the? No, actually, I don't want to answer that one right now. That's too big. Effective container the camera controller, which would be easier to do. Okay, so the easiest. Okay. Sorry, I should actually say what the question is rather than assuming you all just mind read me there. So suppose you need.
This is not Jeopardy, where they get to guess the question.
That's right. Yeah. So suppose you need an RTS-style camera class that can affect multiple pawns characters through a U input component. So I don't think your camera class should be. I think you want an RTS controller class, not a camera class, that can affect these pawns and characters through a U input component. Should I attach the affected container, which I guess is the list of pawns or characters, to the camera or to the controller? The controller. You should probably be doing your input either through your invisible pawn that the camera follows, and that's just a dummy pawn that tells the camera where to go and manages your input, or through the controller. I actually like to do it on the pawn. It's just the habit that I got into early on, and it's easy.
Same. Yeah.
Yeah.
Because like if you kill your pawn, the player controller can then do something else with the new pawn, right? Like with those inputs and things. And so hardwiring them up at that level is a little bit less future-proof than doing it down, you know, in the actual pawn.
Yeah, I kind of like that. And if you ever have, you know, not just kill your pawn, but if you have like a Halo game where now I'm in
A Jeep,
road vehicle,
right.
now I'm in a flying
Sorry,
vehicle.
a Warthog.
Not TM. Yeah, so for something like that, then you get one. Each class has only its own controls and its own interpretation of the inputs, as opposed to the controller having like switch what am I
Right.
controlling. Yeah, so I would say that don't do it directly on the camera. Do it through either a pawn or a controller class.
Cool.
All right,
Okay, well
great.
that was one more.
Thank
Yeah.
you so much for coming on and doing this. I know we learn a lot, and
Yeah, totally.
You guys seem to know
There's-
some things in advance.
I take it from a different perspective is all. It's just like-
Yeah.
Sure.
But so yeah, thanks again. And so we're actually starting to do surveys at the end of these. I'm going to be dropping one into chat, and if you'll fill that out for us and let us know how we're doing or ways we can improve this stream, we really would love to get feedback from you all. And let's see. So SIGGRAPH is next week. There's going to be a handful of folks out there. Some big announcements coming up. If you're out there, find folks that are from Epic. Say hello.
Yep.
We always love to see you. So quickly, David Stelzer is going to be at Casual Connect.
Also next week.
Yeah, let's have all the events at the same time.
Yay, industry.
So he's doing a talk on August 3rd at 1 p.m. He's going to be discussing developing success in mobile with Unreal Engine. So if you happen to be at Casual Connect, go say hi and check that out. Also, we have our marketplace sale going on through August 1st. So if there's still some of those assets you're looking to grab, some of those are off up to 90%. So there's some really good deals, and you can get some
there's a
really
lot of great content in there.
I think like 12, we have
1,200
over 1,200
over 1,200
assets on sale. So go check that out.
I know I haven't dove in myself yet, but the weekend is coming. Yes.
Is that when it's dangerous, right?
Yes, every time.
We'll also be doing our first NVIDIA Edge announced tomorrow. We've had a bunch of entries on Twitter, Instagram, and Facebook. So we've sorted through all of them, and we're really excited to announce our first round.
Yeah.
So keep an eye out on that for tomorrow. And then real quick, our meetup, if you're in Raleigh, is tonight at 7 at Craft Public House if you're in the area and would like to join us. Anything else you can think of?
Yeah, we got a next round of dev grants are coming up soon. I'm not really sure exactly when, but if you've been waiting around about to hear back from the program, keep an eye out on the blog and our social. So we're excited to reward some amazing projects with some funding. So it ought to be really great. So keep an eye out for that.
All right. So as always, follow us on Twitch, Twitter, Facebook, YouTube, and we'll see you next week.
Thanks, everyone.